Test. Test, test, okay. All right, can you guys hear me okay? Okay, all right. It's 3:15, we'll let the rest of the guys kind of come in, but I want to go ahead and get started here. My name is Wes Bunn, I'm with Epic Games, and in this session we're going to be talking about animation and creating playable characters inside of Unreal Engine 4. There's absolutely too much stuff to cover in an hour here, so we're going to approach some things at a high level and try to give you the most important bits of information to get you up and running in this session creating playable characters. This session is intended for those of you that are relatively new to Unreal Engine, thinking about making the jump, haven't quite tried it yet, as well as some intermediate UE4 knowledge, because we're going to cover some optimization things that you can do to make your characters and your game more efficient in the long run. So before we get started, I wanted to highlight what it is we're going to cover here today. So first and foremost, we'll talk about how to get started and bringing in the types of assets that we support. We'll also talk about the single most important thing inside of UE4 and working with animation, which is the skeleton asset. It's super important that you understand what this asset is and how it's used with animation in UE4. We'll also talk about the different types of animation assets that you can create and what they're used for. From there, let's see, we'll show you the quickest way to get a playable character up and running in UE4. In fact, we'll actually create one here together really quickly. We'll create the basic navigation going from an idle to a walk to a run. We'll define the logic that allows us to go from our movement to jumping. We'll also implement two different melee attacks just to show you kind of the best practices for implementing things like this and talk about that as we go along. We'll also set it up so that you can blend those attacks with our navigation, which is one of the things that's pretty cool that you can do inside the engine here. We'll do a little bit of blueprint visual scripting. For those of you that aren't aware, this is our visual scripting system inside Unreal Engine. It's pretty much used everywhere throughout the engine, so if you haven't experimented with it yet, I highly recommend that you do. It's very user-friendly. Let's see, during the character setup, we'll also be showing some of the workflows that we use at Epic and talk about some of the best practices. And then we'll also wrap up with some of the optimizations that you can do to your animation blueprints, which we'll talk about here in a little bit. So first things first, you'll need some content in the FBX file format that you want to bring into the engine. This could be skeletal meshes, animations, etc. There are several documentation pages regarding the do's and don'ts of FBX importing. That could be its own separate talk. So what I've done here is linked them in this PowerPoint. At the end of the session, I'll give you a link where you guys can download this PowerPoint as well as the project that we're going to create here together a little bit later. But once you have your content in and begin the import process, you'll get the FBX Import Options dialog box, which should look like this. This enables you to define just how you want to go about importing your content into the engine and provide several different options that you can use to tailor your import process. Once you're satisfied and you click import, your content will be imported, and depending on your settings, various assets will be created for you automatically inside the engine. Your mesh will be imported, a physics asset will be created, materials and textures will be created and applied to your character, and most importantly, if you do not define one as part of the import process, a skeleton asset will be created, which is this asset here. We're going to go into depth a little bit about this right now. So skeleton assets are what drive animation in UE4 and is what allows you to share animations between skeletal meshes, pending certain requirements are met, which we're going to talk about. If you've already worked with animation in UE4, this may not be new to you at all. You may know all about skeleton assets, but we have licensees and indies and people that are working with UE4 now that still have trouble sharing animations with characters, and they're not 100% why. That's because the skeleton asset in UE4 is really just a list of bone and hierarchy information, and that's information is used to drive the animation inside of UE4. Among other things, but we're not going to really jump into those things in this session. It's a bit outside of the scope of this presentation, but it's really just to drive the animation. You may think of a skeleton asset, something like this. If you're familiar working in Max or Maya, this is what a physical skeleton looks like. It is the same in Unreal, but we want you to think of it more like this list of information, okay? Because that's where the confusion lies in there. A lot of people, when they import characters into UE4, they think that each skeletal mesh has to have their own individual skeleton asset. And that's not necessarily true. In order to share animations, the characters have to share the same skeleton asset. Okay? So we talked about you could share skeleton assets as long as certain rules are met, which we're going to talk about those rules here in a second. And as long as the bone name and hierarchy is the same, as long as you're not changing the bone names or the hierarchy inside of your skeletal meshes as you're creating them and then exporting them, you can share skeleton assets inside of Unreal Engine 4. So you go through, you create your character, it's got its rig, it's all set up, you export it as an FBX, you bring it into UE4, then you want to create another character, use that same setup, that same rig that you did before, and don't change any of your bone names or the hierarchy, and you can share assets inside of UE4. Okay? Again, so as long as the bone hierarchy is consistent. So I kind of wanted to break that sharing those sharing rules down here. So I'm going to give you a quick example. So here is a setup for potentially an arm. It's a 3-bone setup for an arm, and we've named it 1, 2, and 3, or whatever we decided to call it. One of the things that you can do with your skeletal meshes in your external applications is add 2 things. So as long as you're adding to your skeleton, for instance, you have a character that has a head, you want to add some extra bones for a ponytail, when you bring that character into UE4, you could still share skeleton assets. Any characters that don't have those bones will just not use that data. A lot of people think because you're adding extra arms or even potentially extra or ponytails or extra arms or whatever, they think that you can't share skeleton assets at that point, but you can as long as you're not changing the naming convention or the hierarchy. Okay? That's when it becomes an issue. So here we have that same example. On the left we have the 1, 2, 3. That's our on the right, excuse me now. We have our 1, 2, 3 bone chain there, but we've changed the hierarchy and we've named it 1, 3, 2. That would be an issue when you try to import your characters. So just things to consider when you're setting up your characters externally and you want to bring them into the engine. Try to share your rig and your bone information. When you do have your characters ready to bring into the engine, you'll be presented with the option of choosing a skeleton asset. This is what drives the animation in UE4. You can define that as part of the FBX Import Options. There's a drop-down. Just click the drop-down and assign your skeleton asset. So again, you have one character that you've imported. He's all set up. He has animations. You go and create another character. You want to bring that character in that was set up the same way. At that point to the skeleton that you've already created, because that will allow you to share animations. So it's this option right here. And when you share that skeleton asset, those skeleton meshes can share animation. And not only that, they can also share blueprint logic. So if you've created a character that can run around and jump and has all this logic defined in their animation blueprint, there's no need to recreate that for a secondary character. Just import it in, point it to the skeleton. They can share animation blueprints at that point. Okay, so it's super important that you understand that what skeleton assets are and how they're used inside of Unreal Engine. There's also a video series that I've done that breaks this down in much greater detail. If you have not seen it already, it's linked in this PowerPoint here. It breaks down not only what to do when you are sharing skeleton assets, but in those situations where you cannot share skeleton assets, the bone hierarchy is vastly different, or you've named the bones differently. One person worked on one character, another worked on another. They're the same type of humanoid character, but the bone names are different. You could use some retargeting, animation retargeting. We have a system inside of UE4 that will allow you to retarget animations to different skeletons. And that video series will cover that, as well as other things like using sockets, and this allows you to attach things to characters, and they'll automatically be animated as a person carrying a weapon or something like that, as well as creating what we call notifies, which allow you to attach events within your animation. So you have a character that's running across the field and you want it to kick up some dust, you can attach a particle effect that way with a notify. Okay, so once you've got your content in, what can you do with it? There's a bunch of assets that you can use to create your characters and get them up and running. You can do this inside of our content browser by right-clicking or clicking the Add New button. I'm going to quickly highlight these because I want to jump into Unreal Engine and actually start building something here. Some of you may have already worked with these. If not, I'm going to recap them really quickly. So we have our aim offset, which is a way to blend a series of animations based on input values. This is typically used for aiming a weapon. But you could also use it for things like having your character kind of looking around based on mouse input. You could use an aim offset for that, or a character holding a flashlight, blending between those poses with an aim offset automatically. We also have animation blueprints, which we're going to start working with here in a moment. This allows you to define the logic for your characters, as well as gives you runtime control of the skeleton. So you can directly manipulate the bones of a skeleton at runtime with an animation blueprint. And we're going to do a little bit of that as well. We also have animation composites, which are just assets that allow you to join animation sequences together. So you have a series of animations, 3 animations, you want to combine them into one animation and call just that animation. You can do that with an animation composite asset. We also have animation montages, which are a special type of asset that you can use for one-off animations or set up logic-based animation switching or looping. We're going to use this a little bit later if some of you have worked with an animation montage. We're also going to talk about best practices with animation montages, because we see a lot of licensees and indies not knowing when to use animation montages versus putting it inside of our normal game state machine for our animating our character. We'll talk about that a little bit later. We also have blend spaces, which are similar to an aim offset, but are typically used to blend navigation, locomotion, so forward, back, left, and right. We can blend between those based on input values. So whatever the character is doing, we can automatically blend between those poses with a blend space. We're going to use one of those as well in a moment. Then we have level sequences and paper flipbook. These are 2 assets, not necessarily related to animation, but can be used with our sequencer tool, which is used for cinematics. We can create cinematics with this and apply animations to our cinematics, or with our paper 2D tool set using our paper flipbook to create animations in 2D. And then finally, we have pose assets, which is a way to provide curve-driven animation. If you want to drive morph targets or anything like that, you could do that with a pose asset inside of the engine. It's just a curve-driven animation tool that you could use inside of the engine. These are the core assets that you can create, and you can do all sorts of things with them. But what I want to do now is actually jump into the engine and actually build a character here, see how quickly we could do that. So I'm going to try and give you the quickest way to get a character up and playable in UE4. Again, if you are new to UE4, this would be one of the methods that I would recommend to get your characters up and running. The first thing that I would probably do is use our third-person blueprint template. So it's a template project that already has a character that runs around inside the level. All the logic's already built for you. There's no need to reinvent the wheel. Go ahead and use that stuff. It'll give you a leg up in starting off your project. So once I've created my project with the blueprint third-person template, from there I would import my skeletal mesh and all my animations that I want to use. From there, I'd probably create a blend space for my navigation, just so I can have that smooth blend between my navigation states. After that, I'd probably create an animation blueprint to define the state machine for my game logic for determining when my character should be in a jump pose versus walking versus running, etc. And yep, create my basic state machine. And then after that, our character should be pretty much functional at that point. We could swap in our mesh for the third-person character that's used in the template with our own mesh at that point. Then we'd also swap in the animation blueprint that we created for the default one, just so that we have our data inside of our blueprint there. And then finally, profit. At least we'd have a good start to creating our game. We've taken out the mystery of phase 2 there. So what I want to do is actually jump into the engine. It's one thing to talk about this in PowerPoint. I'm actually going to hop out of PowerPoint land for a second and go over to Unreal Engine. So here's our project browser there, if you have not worked with UE before. Oh, it's not the browser. Yep, let me kill my PowerPoint maybe. See it now? Nope. I'm just going to kill PowerPoint. And I killed everything, of course. Let's see, there we go. There we go, all right. I promise it worked better 5 minutes ago. So our project browser here, we're on the new project tab. We would create a third-person blueprint template here and just create our project. We've already done that, so we don't have to sit here and wait for it to load. And here is a brand new project. Let's see, first thing I'd do is probably just create a folder just to keep things nice and organized. So inside of the content folder here, I would just right-click and create a new folder and just call it character. Like so. And inside of it, I'd have 2 folders, one for my mesh, one for my animations, just to keep things nice and tidy. So create a new folder and just call it mesh. And then another one called animation. So. And inside my mesh folder, I'm going to import my mesh here. There's a couple different ways you can do that. You can do it from the import button here. You can right-click and import as well. Or you can just drag and drop directly into the content browser, which I'm going to do here. I have a folder here on the desktop. So here's a folder with some animations in it. These are just animations that I pulled from Mixamo. If you guys have been trying to use Mixamo stuff and had a little bit of trouble getting it up and running, and we're actually going to do that now. So let's see. Let's grab our mutant character here. So it's just a character that I pulled from Mixamo. And I'm just going to drag and drop him into the content browser. And it should bring up that FBX Import Options dialog box like I mentioned. At this point, if I already imported a Mixamo character, I would look at and see if I could use that skeleton. Now, right now, if I try to use the UE4 mannequin skeleton, I'm going to show this in a moment, the bone hierarchy and naming conventions are different. So this is why we cannot use this skeleton at this point. So we're going to have to create a new one at this point. So I'm going to leave this field blank. And let's see, I think let's go ahead and just hit import. Might get a couple errors here, but let's see, our warnings. So we'll import our mesh into the project. There's some warnings about smoothing groups, which this doesn't have, and some other stuff that's not super important. We can just minimize that. So we have our character inside of the engine here. I'm just going to pull it up so you can see it a little bit. It's created a texture, material, physics asset. There's that skeleton asset that it created for us as well. If I open that up, there's that bone and hierarchy information right here that is used to drive animation. And if I look at the third-person character, under character mesh skeleton, you're going to see that it's called root, pelvis, spino 1, spino 2. It's essentially a humanoid type character, but the naming conventions are different. Again, so this is why we cannot share skeleton assets at this point. If I were doing this project for real and I was using Mixamo content, I would create a base character that has all the features that I would want, import that character, create a skeleton for it, and then every additional character that I want, I would point it to that skeleton, just so that we can share animations. Okay, so let's go ahead and bring in our animations that I have for this character here. So I'm going to go ahead and move that over and just take these. So I have a couple different animations here. Don't need to re-import the mesh. And we'll bring those in. And when we do, we get the import options dialog box, and it's asking what skeleton do we want to associate this with. Now we just created that skeleton when we imported our mesh. So we're going to point it to that mutant skeleton that we just created. Okay, so the animation knows what bones, where the bone hierarchy is, what the information is, so that it can drive those animations. So I'm going to import all of those real quick. So there we go. We have a character with a bunch of different animations here that we've created externally. We have idles, we have loops, we have a couple of melee attacks. First thing that I would do is probably create a blend space, like we outlined a moment ago, just so that I can blend from my idle to my walk and to my run. Okay, so I'm going to right-click in the content browser. And under animation, there's two types of blend spaces. There's multi-directional blend spaces. So if you have lateral movement, if you have a character that can move forward, back, left, and right, you'd want to use that type of blend space. There's also one-dimensional blend spaces. Our character is going to run one-dimensionally, and then the camera is going to follow him. So we're going to use a blend space 1D here. Again, now it's going to say what skeleton are we going to reference here. We're going to reference our mutant skeleton there. And we'll just call it idle move. Blend space, something like that. And when we open it up, we have the ability to define what parameters and what animations are actually going to be included in this blend space. So in the middle here, we have this little graph. It goes from 0 to 100. Right now it says none down here. There's no property that's going to be driving it. So what we'll do is we can go over to the details panel over here, and we can expand this section here. And we're going to define the parameter that's going to drive the blending of our animations. Okay, so that parameter is going to be speed. Okay, so if our character is not moving, he's going to be idling. As speed increases, we're going to switch from walking to running. So we'll call this speed. Okay. Right now, the access values go from 0 to 100. I'm going to bump that up just a little bit. We'll bump it to something like 220, just to give us a little bit more movement speed in game. And let's see, the other thing that we can do to smooth out our blending process, there's an interpolation time here. How fast do I get from point A to point B here? Currently it's set to 0. I'm going to bump this up so that it blends a little bit better. And you'll see the effects of this here in a moment. So I'm going to bump this up to, let's say, 0.5 for now. So we have our character there. We have speed at the bottom now. We have 0. So when we're at 0, we're idling. And when we're at 220, our max, we're running. So we can go to our asset browser and just take this idle that we have here, and just drag it and drop it in. So now our character is idling. We're at 0. And we have a run here. We just take this and drag and drop it at the end. And we have a run. So you can see as we start out as 0, let me go ahead and just move this up a little bit so you can see. So we start out at 0, character is idling, but as we increase in speed, it starts to blend automatically into an actual run when we reach our top speed. Okay, so that's a blend space. It's much easier to create this asset, drive the parameter, and have the parameter do the blending for us than trying to manually do this ourselves. So we have this space in the middle here. What we're going to do there is just we're going to add a walk in there. So we have our idle to our walk. And then when we run, we'll actually start running. So I'm going to go ahead and save that out. Okay. So we have our blend space. The next thing I'd do is create an animation blueprint and create the basic state machine for this character so that I can have him use this blend space and as well as jump. We're going to set that up as well. So I'm going to right click. And under animation, there's an animation blueprint. And it's going to ask, what skeleton? Okay, there's also a pick parent class up here. 99% of the time, you won't have to worry about this unless you're doing things with vehicles and stuff like that. It's really just worried about what skeleton are we referencing. Again, we're referencing our mutant skeleton. You can see how important this asset is now. It's used pretty much everywhere. So we're referencing our skeleton asset. And I'll just call this the mutant anim BP. Okay. And if you open this up, don't be alarmed. There's a graph here. I know you didn't sign up for graphs, but it's part of Blueprint, and it's used throughout our engine. We're going to quickly highlight what's going on in here. So we have our Animgraph, which updates our final animation pose. So this big guy here. This is the actual pose that our character will be in during our moment-to-moment gameplay. Then we have our event graph. This is used to drive and populate variables that dictate what pose we're going to be in on our Animgraph. Now, don't be alarmed. We're going to set this up, and you'll see this all come together here in a second. The good thing is some of this work has already been done for us. So in the essence of time, let's use what we have. If we look at our folder structure here and we go under Mannequin and Animations, there's already an animation blueprint set up for this playable character in here. In fact, if I play in the level here, you can see there's a character that can run around. It has logic. It can jump. All this is done for us. There's no need to reinvent the wheel here. So I'm going to open up this animation blueprint. You can see if we go to the event graph, it's already got some logic here. What on earth are all of these things? These are basically what's happening here is we're seeing, are we in game? Do we have a player that we're controlling? Is that player currently in the air? If he's in the air, so that'll allow us to determine if we want to jump or not. And what's the speed of that character so that we can use a blend space? So I'm going to select all of this and just copy it. Control C and then come over to ours, delete this node and just paste it. So now we have that same logic in our blueprint. Now there's a couple warnings here. That's because it's saying it doesn't know about this is in air variable and it doesn't know what speed is. One of the things that we introduced recently that I'm very thankful for is that you can right click on these and create variables for these right inside of the graph here. So I'll create a variable to determine whether or not we're in air and also create a variable to determine our speed. Okay? So it's created those variables down here for us. If I compile, those warnings should go away. So our event graph is pretty much set up. We don't really need to do anything else in it. We know when we're controlling a character. We know when we're in air. We know what our speed is going to be with this graph set up here. So what I do is go over to the Animgraph now and create our poses based on those variables. So what we do is we right click in here and we're going to create a state machine. Okay, so state machine. Okay. And we'll just call it the basic locomotion. That. So depending on what the result of our state machine is, it's going to give us an output pose, that's going to feed into our final animation pose. So if we're running, walking, jumping, it'll come out and result in our final pose there. So let's set up this state machine really quick. So inside of it, the first thing that we're going to need is our blend space that we created. If I drag this in like so, we have this entry point. So where we start is at our idle and blend. Okay, so if we compile, character goes into an idle. Okay, because right now it's using a blend space. And the value is 0, our speed is 0, so he's idling. If I jump into this, you're going to see there's a blend space and it's asking for that speed value. What is the value of our speed? Well, we just created a variable that's going to tell us what our speed is. We could take this, just drop it on top. So based on this value, it's going to update our blend space with the correct pose. if we compile and save, and we play in the editor, well, not quite playing yet. We need to swap in our character and swap out the mesh. So there's already a character in here. I'm going to select this guy, and over in the details panel, we're going to choose our mesh, swap in our mesh, swap in our animation blueprint. So there's our mesh. And the animation blueprint is our mutant blueprint. So now if we play, we have a character in there that's idling and starts running. Now it's popping a little bit. We're going to explain why here in a moment. The speed is quite fast too, but we've already got a character that's up and running, responding to our input. Now this input can be controlled with WASD or a joystick. This template was already set up for us. Okay. So what we're going to do is let's go ahead and make some quick changes to this blueprint. So this is our character. Just open it up. And there's all kinds of logic in here that's been set up for us. This determines our input and actually moves the character in the level. We're not actually worried about that right now because it's already set up for us. The only thing we're going to do is change the max walk speed of this character because it was kind of moving a little bit too fast. You could search for that by just saying max walk speed. So it's currently set to a speed of 600, which was quite fast. We said our max run speed was going to be 220. That's what we set up in our BlendSpace. But we don't want to start out running. We're going to start out walking. So I'm going to lower this to something like 120 as our walk speed. We also have a crouched speed here as well, which we're not using for this particular demo, but we'll set our max walk speed to 120. The next thing I would do is provide a way for us to go from walking to running, sprinting. Typically that's left shift. If you played any FPS or any other game out there, it's left shift would be running. So we're going to use that. We could right click and we could just search for left shift. So we have a left shift, and this basically will tell us when it's pressed and when it's released. Again, no, you didn't sign up for blueprints, but this is going to be the extent of our blueprint logic that we're going to be doing right here. So we basically just set our max walk speed. What we could do is we take this character movement component here and we say set max walk speed, just like we did. We can now set that whenever we press left shift or whenever we release left shift. So when we press it, the character is going to go up to 220, our max walk speed. And I'm just going to copy and paste that, plug that in here, plug that in there like that. And when we release it, we'll return back to 120, our normal walk speed. Okay, the only other thing I would do for this is just to give us an indication of when we are actually sprinting in the game. I'll create a variable just to let us know true or false whether we're sprinting or not. So I'll create a variable over here just really quickly and just say is sprinting. Just mark like so. And if I hold Alt and bring it in, I can actually set that. So are we sprinting? Yes. Copy and paste it. Are we sprinting now? So that's sprinting, making our character sprint. So I'll just say sprinting. So, okay. So if I play now, I should see, by default we start walking, and then when I hold left shift, it goes into a sprint. Now you notice the interpolation time going from our walk, it's much smoother. So he's kind of walking, and then when I hold down shift, he kind of blends into it a little bit. A lot of that is being driven by that interpolation setting that we set inside of our BlendSpace. So if we take a look at that again real quick. So here's our BlendSpace. This value here, this interpolation time, if I were to set that to 0, he's going to pop between those these frames here. It's just a way of giving you, actually the tooltip says it, used for smoother interpolation. So just a quick tip there that you can use that to smooth things out. So how are we on time? Okay, we're okay. So we have a character, but if I jump, we've got this problem here. It's kind of run jumping there. If you've worked with Mixamo content, you've probably seen this, and it drives me a little bit nuts. But we have a jump inside of our little animation pack here that we have. If I bring this up. So we have this jump animation here, but there's a couple of things wrong with this jump. Okay, for NPCs, this is perfectly fine. For gameplay reasons, this is not going to suffice because the jump, start, end, and loop are all baked into this animation here. Not only that, the lead up to this jump is quite long. So when I press spacebar, it takes all this time to get to the point where I actually jump. So personally, I would chop almost all of this section out, and I would split this up into 3 different animations, which I've done to save us time here. Essentially, we could have situations where the player is jumping off this little box here, jumping off this platform or jumping off way off the top of this wall. So we don't know how long the player is going to be in air. So that's why we need to split this up into 3 different animations. Okay, that's kind of what we've done here. I've done it a little bit ahead of time, save us some time. So I've created a start, created an end, and created a loop animation. Okay, and we're going to use our state machine to switch between those. Okay, so we'll go to our Anim blueprint here. So we already have one state, knowing when we're idling, walking, and running. We could have made 3 animations in here, one for idle, one for walk, one for run, and transition between those. But we're letting our BlendSpace do all that work for us. But we do need the states for jumping, so we're going to add those. So I'm going to say jump start. I'm just going to drag that into the graph. Jump loop, and jump in. Okay. Move this over. Okay, so we have these 3 additional states here. We want to transition between these 3 states. So what we could do is take our BlendSpace here, and we can drag a wire and connect it to our jump start. The only thing that's going to come after jump start is jump loop, so we can just connect a wire to that. And after jump loop, we're going to go to jump end, kind of see where I'm going with this, and then back to idle. This is our basic state machine here. This is the extent of the state machine that we're going to be doing. Okay? So these little icons in here allow us to define the rules for transitioning between these states. So by default, we're idling, or we're using our BlendSpace to determine when we're actually moving. But when we move out of idle, the thing that's going to tell us whether or not we should be jumping is that variable that we created a little while ago called isInAir. Okay? So we go into this, we double click on it, say, can we enter that transition? Well, it's going to be based on whether or not we're in air. So just drag and drop that on top, like so. Okay. Following jump start is jump loop. The only thing, like I said, the only way that this can go is from the start to the loop. So inside of this, what we're going to do is just determine how much time left is in our jump start. So when we're close to finishing our jump start, we're going to automatically move to the loop. Okay, so we can right click and we just say time remaining. So we have this time remaining jump start there. There we go. It's going to give us a float value, which we could drag off this and just say, does this equal, is it less than or equal to 0.1? Is the animation almost done? If it is, then we can transition to our jump loop. Okay. 2 more that we need to do. So once we're done looping and we want to end our jump, well, that's going to be determined on whether or not we are still in air or not. So we're going to take this, drag it into the graph and get it, and then we'll just say not. Okay. Are we not in air anymore? If not, then we're going to go to jump end. So it's going to go right down to jump in. And then similar to what we did on this side over here with the time remaining, we're going to go from the end jump animation into our idle once it's close to finishing that animation. So inside of this, we could just say time remaining again. Jump end. Okay. Is that less than or equal to 0.1, close to being done? So. Okay. So now we have a simple state machine here. There's one other thing that we're going to do to kind of smooth things out. Another pro tip here. If you select these transition rules here, over in the details panel in the far right here, there's an automatic blend duration. So for our particular instance, we don't want this 0.2 blend. We're going to cut that in half. We still want a little bit of a blend, but this blend is a little bit too long. If I were to test this inside of the engine here, kind of see, let me see if I can compile. So when I check this option here, see how he's kind of popping between those? You could also see the state machine working here. So I'm in idle, I'm now jumping, went from jump start to loop, I'm no longer in air, landed. But there's some pop of the animation. That's partly due to this here, part of that blend duration. So we're going to cut that in half, say 0.1. Okay. If we actually test this inside the engine, it should, fingers crossed, work. Okay. It's not the fanciest of loop animations. I would probably have some secondary motion of the character kind of falling, but I chopped this animation up actually inside of Unreal. That's another thing that you can do. You can create animations from existing animations within Unreal. Okay, you can take a pose, modify it, keyframe it inside of Unreal and animate it there. But now we have a character that can actually jump. The other thing that's really useful is that this also takes care of falling for us, which the other animation wouldn't. So if I fall off of this, he's in air, he goes right into it. Okay? So it's automatically done for us. And the other thing, like we mentioned, we could be jumping up on here, we could be jumping up on there. We could have a long jump down, like so. Okay? time, okay. Okay, so we've got a basic state machine in place here. I'll go ahead and close some of these windows. Okay. And this is pretty much the extent of I want to go with our state machine, okay? A lot of people try to put melee animations and all kinds of different actions inside of this state machine. Your best bet is to create a state machine that handles just locomotion, so that it's purely locomotion, and then save that off and then repurpose it and use it elsewhere within your animation blueprints, which we're going to do in a moment. Those types of one-off animations can be handled with animation montages or other animation assets. Okay, so what we're going to do is we're going to go back to the top level here of our state machine. Let's split this off. Okay, we're going to drag off of this and say cache. Okay, so it's new saved cache pose. Okay, this is basically going to store that so that we can use it anywhere else inside of our graph. So I'm going to hit F2 on this and just call this basic, or I can't call it basic loco. Sorry, basic loco. Okay. So if we were to say use basic loco, let's see, like this, and we were to plug that directly in, it's essentially the same thing as plugging this wire into that at this point. Okay, it's just, we can repurpose this, we can use this multiple times inside of our graph and blend it with other things if we need to. Okay, that's what we're going to do now. So let's go ahead and just kill all this for a second. Okay. So our character can run, walk, jump. Let's go ahead and give him an animation of attacking. And this is where we're going to use an animation montage for this, okay? So we can right click, we can go to animation. There's an animation montage, okay? Go ahead and select that. Again, what skeleton are we using? Again, super important. The mutant skeleton, okay? We'll just call this attack. Okay. Double click and open it up. Let's see, let's go ahead and move that over. This section in the middle here, we can define the animations that comprise our montage. We have a couple melee animations. We can throw both of those in here. What's really cool is if we take like our punch, here's our punch, we drag that in, and our swiping, drag that in, and we were to play this. See, we have a like right hook and the big swiping attack, like so. It's playing these animations back to back, but what's cool is that you can section these off and then tell through Blueprint or your animation blueprint which sections you want to actually use, okay? So we can come in here and we could say at the start of our left attack, this attack here, we can add a section in there. Let's just say left attack, like so. Okay, and we can add another section for right attack. Let me just drag this over, get rid of that default. So by default, there's a section here. We don't need this anymore, so I'm just going to delete that. So we have right attack and left attack. And if I pull this up, what we could do is we can, let's see if we play. You can see it's intelligently looping just that particular section. So we could create a combo system where it plays melee attack A and melee attack B only. And if the button is still held down, transition to melee attack C. That can all be done inside of an animation montage, which if you did that in a state machine would be a lot more complex, a lot more difficult to manage. The other thing that you can do with this, if you're making a fighting game, init, commit, and resolve frames are very important. You can set those up inside of the animation montage. When should the character be able to cancel attack? Where's the counter window? That can be done inside of a montage, which if you did it in an animation blueprint, it's a lot harder. So we have our animation montage here. We have some sections. In order to make this work, inside of the animation blueprint, it uses what's called a slot node, okay? Over on the right here, we have this default slot. We could use that. I'm going to give it a little bit more descriptive name for this. Click this button here. We can add a slot, which will just say attack slot, like so. And let's make sure that we're using attack slot, like so. So our character kind of T-posed theirs, but if we close this out and reopen it, it should be fine. Let me just double check. Yeah, it should be fine. So it's now assigned to this attack slot. Whenever we call that, this animation will get played. Okay, so what we could do inside of our animation blueprint here, I'm going to use our locomotion cache that we created here. Just use basic locomotion. And we're going to use a slot node, like we said, so slot. Okay, and plug this in and make sure that we're using the attack slot that we just created. Okay. And I'm going to go ahead and cache this off as well, too, just so we could store it. So we'll say cache use, oops, should be new save cache, okay? So we'll say attack, something like that, okay? So if we were to say, let's right click and use attack, let me compile first. Compile, and we say use, keep typing user. Use attack cache. If we were to plug this in, it should work, okay? So let's go ahead and compile that. You can see both of these all of these are running at the same time. We're running our state machine to get the basic locomotion pose. We're then blending that on top of our animation montage to give us the attack pose. This is something that we do a lot at Epic, splitting things off like this. We'll have upper body and lower body state machines, cache those off to blend those with any other kind of skeletal controls that we want or IK solutions that we want to add to our blueprint, our animation blueprint. This is typically the workflow that we use, things like this. Okay, so let's go ahead and test this real quick. Let's make sure that we give a way for our player to actually attack, because right now we have no way to respond to input and actually attack. So we can go edit our character's blueprint here. So we have left shift for sprinting. We'll just say left and right mouse button, so just left mouse button and right mouse button. Okay. And what we're looking for is play a montage. So play Montage. There it is. Animation montage. So what we'll do, plug that in. That's going to ask what montage do we want to play? Well, the one that we created called attack. And we can also choose the start section name. So now we could say if it's the left mouse button, jump directly to left attack. If it's the right mouse button, use right attack. So we're going to say left attack. And we'll copy and paste this. And we'll say right attack. Okay, so we compile, save. Again, this was done outside of the state machine. Okay, so if we play, we should be able to press our left button. It does a swiping tack there. Press our right button, does that little hook. And we haven't set up any init and commit resolve frames for this, so we could actually start and then just go directly to something else, kind of combo it. But we do have a problem. As long as we start moving, the character is going to start playing that attack while we're moving. Okay? So this is where we get into skeletal controls. Okay? So what we want to have happen is when our character is standing still, if we're coming to chop down this little thing here, we want to have the character do that full wind up and that attack on it. However, if we're walking, we only want the upper half of the body to play the melee attack. Okay, so we're going to blend our locomotion with our attack. Okay, we're going to do that now. So we have our locomotion state. We have an attack here. To do this, what we need to do is create a layered blend per bone. Okay, so this node here allows us to define a specific bone at which point we want to start blending from. Okay, so we have two poses here. What we'll do is we'll take our basic locomotion, plug that in, and we'll take our attack, plug that in. Okay. Now we don't want to directly plug this in, although this would work. We don't want to directly plug this in right now. We want to be able to determine whether or not our character is standing still or moving. Okay. And the other thing that we need to do, before I forget, is on our blend, we want to specify which bone we want to start blending at. So we go to our layer setup here. We can specify the bone at which we want to start blending, which I believe it's called spine 1. If we look, probably going to start either from spine or spine 1, maybe just spine, not quite sure which one will look better. We'll try spine 1. So we're going to blend the upper half with the attack here, and the lower half will have our locomotion. Okay, so we'll use spine 1. The blend depth, I'll set that to 2, and we do want to rotate, so let's go ahead and check that. Compile. Let's go ahead and move this over. So we want to determine whether or not we're moving. We have a blend node called, if we right-click, say blend bool. So blend poses based on the value of a Boolean, true or false variable. Okay, so what we're going to do is move this over. So we're going to plug that into our true. Okay, and if it's false, we're not moving, then we want to play just the attack by itself. So that big wind up, the full body animation. Okay, again, this is Something that we do at Epic, again, full body versus half upper or lower body, splitting things up like this. So we have our attack, so. And that's what we're going to feed into here. Okay. And we do need to create a variable to define whether or not we're moving, which we could do by just right-clicking and saying promote to variable. And I'll call this is moving, something like that. Okay. So if we compile, you can see right now it's false, we're not moving, but if I were to be moving in the game, if our character was running, then it would say we were moving. So we need to go to our event graph and actually set that real quick. And you can see we have this speed value here. If this value is greater than 0, then we're moving. So I'm going to use that to determine and set whether we're moving or not. So we'll just use a true or false statement here. Is speed greater than 0? It is. Then go ahead and set is moving to true. If it's not, then set it to false. Okay? That's determining whether or not you're moving. Okay, so let's just double check. Everything's good. Play. So we're not moving. As soon as I start moving, it plays the upper body only. Okay? So that's runtime skeletal controls inside the engine here. So we have a character that can do all kinds of stuff, but stand still and attack too. Looks like we got about 15 minutes left here. I'm going to go back to PowerPoint land here and talk about some optimization stuff and then try to answer some of your questions. There's one more thing that I wanted to do in here, but we're running a little short on time. Again, I'll give you guys the full project so you guys can check this out and pick it apart. But I did want to hop back to Unreal and talk about some of the optimizations that you can make inside of your blueprints. Let me go ahead and just bring that up. So optimization of animation blueprints, just wanted to touch on that since we did some animation blueprint work. Probably the first thing that you can do inside of your animation blueprints is to make sure that you have an option inside of your project settings called Allow Multi-Threaded Animation Update. It's under the General Settings. This controls whether by default we allow animation blueprint graphs updates to be performed on non-game threads. Okay, this is a little bit programmer talk here. It's all done under the hood, but if you enable this option, essentially it moves all the work that's being done by your animation blueprints off to worker threads so that the game thread can focus on game-specific things. Okay, there's nothing that you have to do to make this work. Okay, the only thing you have to do is specify which blueprints are actually going to take advantage of that. And you can do that inside of the class settings here. There's an option to enable it. The blueprint says use multi-threaded animation update. Okay. Let's go ahead and talk about some of the more forward-facing things that you could do. Animation Fast Path is a thing that we introduced, I think it was engine 4.16 or 4.17. But what this allows you to do, you can enable this inside of your project settings as well under the general settings. It's kind of a lengthy name there. Optimize Anim Blueprint Member Variable Access. It's probably the longest title ever. What this does, though, is rather than making calls to the Blueprint virtual machine to execute Blueprint code, it enables the engine to copy parameters internally and reference those copies. So it's just a more efficient way of running blueprints by reading those copies than going up to the Blueprint virtual machine and executing that logic and then coming back down to the animation blueprint to feed those variables. So it's much more efficient to do it this way. I'll try to give you an example of that. So we have a blueprint here. We've kind of been working with blends before. We have a final animation pose. We have two blend spaces here, but one of them is actually taking in a float value and multiplying that. This is what we mean by executing blueprint logic here. In order to execute that blueprint logic, it has to go up to the blueprint virtual machine, execute code, come back down. That's a less optimal way of doing things, whereas the one below it is just directly reading a float value, that green node there. Any of the nodes that have a lightning bolt attached to them are using FastPath. So whenever you're working inside of an animation blueprint, for those of you that have been working with them, try to avoid using or executing blueprint logic inside of your Animgraphs. Okay, that's the single most important thing you can do to optimize your blueprints. I'll give you another example here. We have a Boolean variable determining which pose we should be in. This is currently using FastPath. It's just reading true or false. Is this value true or false? If walk left is true, then play walk left. If it's not, then play walk right. However, if we were to do something like this and run a check and see what the value of that is, this is executing blueprint code and breaking FastPath. So for animation designers out there, make your programmers happy by using FastPath. You can also enable an option inside of your class settings, inside of the animation blueprint, to warn about your blueprint usage. This is not on by default. You have to enable this yourself. But essentially what this will allow you to do is anytime you do break FastPath, it'll tell you which nodes are the offenders, and you can click inside the compiler results and jump directly to that node and make your optimizations there. So it's just a way to let you know that, hey, you're breaking this. It's less than an optimal way to do this. You should check out this node and see if there's a more optimal way to do it. Okay, just about out of time. I just wanted to really recap really quickly what we covered here today. Again, I'll give you a link to where you can download this presentation as well as the project. It has a little bit more animation stuff in it. But really quickly, we talked about getting started in importing FBX assets, what skeletons are and how important they are, and that they drive animation in UE4. We identified some of the types of animation assets that you can create in UE4 and actually use some of those assets in setting up a character, which we did. We created a playable character in 15 minutes. We also created a BlendSpace for navigation, so we can automatically blend between our poses and give us that nice smooth blend. We created an animation blueprint and a state machine. Very basic state machine. Whenever you're working with state machines, try to split those up into your basic locomotion and then all of your attacks and one-off animations or special case animations. Try to do those in animation montages instead of directly inside of your state machine. Speaking of animation montages, we did one for an attack. Again, we talked about how those are more flexible than using a state machine, especially if you're doing things like combo systems and things like that. It's much easier to chain things together inside of an animation blueprint and get back data than it is from a state machine. Skeletal controls, we did a little bit of blending there. We did a split body, so we had upper body playing an attack while the lower body was walking. There was another skeletal control that I wanted to do, but we're running out of time, so I kind of skipped it. But it's in the project. Essentially, one of the things that we do in Paragon, just to bring the characters a little bit more to life, we have characters that kind of lean into their turn, so when you're running around, I set that up in the project. I was going to set it up here, but I didn't have time. But we're using a skeletal control to do that, so to kind of make the character move in a direction, lean in the way that they're turning. When I get back to headquarters, maybe we'll make a tutorial series with all of this into some more advanced playable characters. We did a little bit of blueprint scripting. Thank you guys for sitting through that. I know you guys didn't sign up for it, but again, blueprint is used everywhere in UE4, so if you haven't experimented with it yet, it's super user-friendly. It's all node-based, all visual. You can do a lot of cool stuff without having to touch any lines of C++ code. Talked about workflow tips as we went along. We also talked about optimization, FastPath, and some of the options that you could set in your project settings that will happen under the hood. And on our documentation pages, there's also some more information on optimization. If you look up anim optimization, there's some C++ stuff in there as well, update rate optimization. Check it out on our documentation pages as well. So that's actually all I have. This link here will give you the presentation with my notes and the actual project. I'll leave it up here so you guys can take a picture. I'll be sticking around if you guys have any questions. Feel free to grab me on the side. That's it. Thank you guys so much.